Now we're talking about the stability. Stability is a state of the equilibrium. So this is a state of the equilibrium. When a state of the equilibrium, we use this equation, stable, neutral, and this one is a less than 0. P minus K is a less than 0. This is stable, equal to 0, neutral, and the greater than 0, unstable. So P and K is this formula here. This is for the state of the stability. The average of Tinning Lam, Tinning also, but imagine a yam, so Tinning in a trouble. I read the name of the P minus K are so we, so Madan, yes, we Tinning it, Tomana needed we, no, a little Jade Chinimashi below, Tomana Jesus will not have Tinning, Chile. Now, Tinning Lam, Tinning in also, and each other so bad, Chile. Now we're talking about this one is a rigid bar with a spring. So in this case, linear Bagley analysis. So linear Bagley analysis, this one is to this angle beta, that way Bagel. So we use this formula to calculate linear Bagley. So the Yabu so it was separation or the angle beta you want to do a lane water, lane water way, or the Nina here, so it's a lane water, giving like lane water and you are to James. And structural instability, we're talking about for the column. For the simply supported column. For the simply supported columns, moment of equilibrium equation, we utilize the equation calculated moment of the equilibrium for the simply supported column. You that is a top of the column, the Jalo, or Eddie Masway, Nimachi, so it was the Nima in the Project Upside. So this one, and when you put this is accurate behavior, this is the point of the verification and the displacement and the load diagram. So this is load and the displacement. We can draw this diagram. Emma, not fail like the you shall moon and set the bony as we demand for your. So in this way that this is two supported here, we process the load P here. This is the simply supported beam. Demand popular bony as we you can't have a warning. So that way we just have Baglen slope can be calculated by both formula. So lane was the other formula in the and that equation for the cantilever lever. So the equation for the cantilever lever. At the time I chose the lever is out of the Nina in the Project today, the Nina in the Project. And also this way the higher order differential equation, the solution method for the higher order differential equation. And all any cantilever being the aloha this way. The more higher order differential equation you don't matter so higher order differential equation here question needed today. Now we're talking about the structural analysis. We utilize those mathematical approach for the structural analysis. And for the structural analysis we have to mention about the boundary condition. So this is the principle, this is the roller support, principle, rotational spring and the transitional spring. Those are kind of the support. The mass in popular bonus in support top Matamu Mimuchi, here's the support of the roller, a big lotara, the mass floating, lotara, Yuishanida, that's when the transition, Yuishanida spring, that's Bolokade, Pide, it has a boundary condition in Pide. And we're talking about the load and the reaction. Though equation for the other time the stability, we use the equation for the all the four equal to 0 or moment equal to 0 for the stability. Thinking in the so not the fairly RD, no, you shall the RD go 0 and so in this case, the difference also local Kenya, this way we there, sub reaction. Now the man RD to fair the ready machine, not Tomya RD bone to my popular hard. So those equations are the if when there's a different causes are look at coming. So we can calculate reaction, so this is the reactions calculation problem. Now the elements we don't be young can add it, the beam up there of the audio, the piano don't be an audio to check the books are checked. And the next one we can talk about the principle of the superposition. So this will say all the forces can be combined. This is the principle of superposition. Audio going to form like that, superposition look at call it. And then we're talking about the flexible member. So this is a relationship between the load shear and the bending moment. This beam is as a loading or the equally distributed load is on this beam. In this case, the weight can calculate for this. This is for strain can be calculated by this formula. ဒီဘေးမှာဆိုရင်တော့အကူကညီမျှစွာပုံတွေဖြန့်ထားတယ်ဖြန့်ထားတယ်အဲ့မှာရှိတဲ့ဓာတ်အားကိုဒီညီမျှရင်းနဲ့တွက်တာဖြစ်တယ် so this is a string equation and a moment equation now moment equation တွေကိုဒီညီမျှရင်းနဲ့တွက်မယ် and a shear bending moment diagram so this diagram we draw the shear force and a bending moment we call it this diagram ဒီမှာတက်ရောက်နေတဲ့ဘေးမှာဆိုရင်တက်ရောက်တဲ့လေအားတွေရှော့ပြအားတွေတွက်ရင်ဒီပုံဒီညီမျှရင်းတွေရရှိမှာဒီပုံတွေရရှိမှာဖြစ်တယ် So this is the shear force and the bending moment diagram of the beam. And also check out the load. This is the shear force bending moment. You know, one cannot see the bending moment and shear force. You also the both. And this is also the fixed pin. We can also calculate this process. Count out the loading and the shear force and the bending moment table. So count the loading, shear force, bending moment. We can draw this diagram. You know, tell me that. One is when bending must be there of the shear force the bending moment you so that is the out and this is also different count loading shear force and bending moment and the one the left of the won't be like that shop ya ari not labor the bending moment you only swear this is also the shear force bending moment the road there the one the shear force the bending moment you the only swear and this we also is the equation we calculate the bending moment equation. The bending moment is the then we're talking about the continuous beam. There are the continuous beams are loading, shear force and bending moment. At set that your whole sense of the bending it shear force the bending moment you the bone swear so this wall is our beam continuous beams are loading, shear force and bending moment. The low bending shear force bending moment bone must swear at it. The bending is shear force bending moment bone and the count of the bend distributed load bending moment diagram. The low one down is where do a bending moment of sweat at bone and the equation to calculate the bending moment. The bending moment with the boat imagine this equation is embedded. This is a technical beam we calculate as a shear force and bending moment. The mass of the low pair of so you must see a shear force and bending moment. Those are the calculations of brought equation. The equation that blow me your credit both are pitted. So this is the equation to calculate the bending moment and shear force. The imagine of blow me your bending moment and shear force credit pitted. And the bend depression. So the bend depressions are equation for the bend depression. That's the bend the air. We are the imagine at 12 pitted. So this is the bend depression equation. And then another thing is a moment area method. So this area is a moment. So this is a bending moment shear force we can calculate by the moment area. The area to you share so not you see the bending moment shear force you sweat up. So this is the beam. This is the beam moment diagram and the bending moment shear force. The beam of bending moment shear force totally. So this is a bending this diagram. The beam of we want the bones where are today. So this is the equation for the circumferential stresses. These circumference ma no se won't have about one time you try to imagine it. This is the circumferential stresses. Se won't have people what it to so this is the kind of this area we can find out the moment of the inertia area. So this is what I did the polymer 12 year now we can also calculate this moments area that can be calculated. So that way this moments area circumferential stretch we calculated, and this way the Z way this a bending thread can be calculated with this Z. So this is the bending thread can be calculated for this equation. So this is for the different formulas of the bending stress calculation. Bending stress calculation and all the center of gravity. Center of gravity baba shi de do a bending stress you try to imagine it today. So the center of gravity and the bending moments are calculation. Center of gravity net bending moments that would try to imagine. So the bending moments Z. So in this case what they are property of the cross section. The section property is Z. So property of cross section is Z. So the take-out area we can also calculate the property of the cross section. The property of cross section we calculate find the equation, property of the cross section equations.